Hello, good morning friends. Welcome back to your favorite channel Code One Digest. Today in this video, we will learn about API Gateway Design Pattern for microservices. I'll explain what is API Gateway Design Pattern and also explain you with the real world example where to use API Gateway Design Pattern, what all the advantages of API Gateway Design Pattern. So stay tuned till end of this video. There are a lot to learn in this video. By the end of this video, you will be master in API Gateway Design Pattern. Friends, in previous video, we discussed about sidecar design pattern. Can you explain what is sidecar design pattern? Kindly provide your answer in the comment section of this video. If you have not seen the previous video, so please go and watch the previous video. The link is provided on your screen and also given in the description section of this video. So for more information, go and watch the previous video on Code One Digest channel. Friends, so here is the agenda for this video today. I'll give you introduction of API Gateway Design Pattern. Then I'll explain the real world example of API Gateway Design Pattern. I'll explain the use cases of API Gateway Design Pattern, where can we use it. We'll understand the benefits of API Gateway Design Pattern in our project. Then I'll summarize the API Gateway Design Pattern. Then next I'll give you a very brief introduction of our next video, that is Aggregator Design Pattern. So stay tuned till end of this video. It is going to be very exciting and there is a lot of learning in this video. Friends, before we proceed in this video, I want you to subscribe my channel to grow Code One Digest family. Friends, I'm creating a lot of quality contents for you, but I'm not getting subscribers. I want you to like, share and subscribe my channel so that I can grow Code One Digest family. Thank you. Okay, friends. So now let's start with API Gateway Design Pattern. What is API Gateway Design Pattern all about? Remember that this is the first design pattern in integration design pattern category for microservices. So what API Gateway Pattern says, API Gateway Pattern is also known as the backend for front-end design pattern. The purpose of API Gateway Design Pattern is to provide single entry point for a group of microservices. It's similar to a facade pattern for object-oriented design, but in this case, it is a part of distributed system. API Gateway sits between the client applications and microservices. API Gateway acts as a reverse proxy which routes requests from client to the services. API Gateway provides other cross-cutting features like authentication, SSL termination, and caching. When you design and build large and complex microservice-based applications with multiple client applications, a good approach to consider using API Gateway. Let's understand some of the key features of API gateways. An API gateway offers multiple features. The most important and foundational features are reverse proxy, or we can say gateway routing. API Gateway offers reverse proxy to redirect or route request to the endpoint of the internal microservices. Gateway provides a single endpoint or URL for the client application and then internally maps the request to a group of internal microservices. This routing feature helps to decouple the client app from microservices. Second important feature is request aggregation. As a part of gateway pattern, you can aggregate multiple client requests targeting the multiple internal microservices into a single client request. This pattern is especially convenient when the client page or screen need information from several microservices. With this approach, the client app sends a single request to API Gateway, then API Gateway dispatches the several requests to internal microservices and then aggregates the result from all the microservices and send it back to the client application. The main benefit and a goal of this design pattern is to reduce the chattiness between the client applications and backend API. Another very important feature of API gateway is cross-cutting concerns. or gateway offloading. Depending on the feature offered by each API gateway product, you can offload some of the functionality from microservices to the gateways. This approach is especially convenient for specialized features that can be complex to implement properly in every internal microservice, such as authentication, authorization, service discovery integration, response caching, retry policy, circuit breaker, QoS, rate limiting, throttling, load balancing, logging and tracing, header query, and so on. Let's understand API gateway design pattern with an example where API gateway is sitting in a microservice-based architecture with a few microservices. Application connects to the single endpoint, the API gateway, that's configured to forward requests to individual microservices. Also, you have to be very careful in implementing the API gateway pattern. Usually, it is not a good idea to have a single API gateway aggregating all the internal microservices of your application. If it does, it acts as a monolithic aggregator or orchestrator and violates the microservices by coupling all the microservices. Hence, it's recommended to split the API gateways into multiple services or multiple smaller API gateways, one per client application form factor. Therefore, the API gateway should be segregated based on business boundaries and the client application, and it should not act as a single aggregator of all the internal microservices. This example shows API gateways are segregated by client type, one for the mobile client and one for the web client. A traditional web application connects to MVC microservice that uses the web API gateway. Let's see another example of insurance system. In this use case, a customer makes regular monthly payment in an insurance system that consists of four microservices deployed as a Lambda function, that is, customer API, communication API, payments API, and sales API. The customer microservice updates the customer database with the monthly payment details. The sales microservice updates the sales database with relevant information that helps the sales team follow with the customer for the cross-selling opportunities. The communication microservice sends a confirmation email to customer after the payment is successful. Finally, the payment microservice is the overall system that the customer used to make their monthly payment. The pattern uses payment microservice to integrate the customer, sales, and communication subsystem. There are three challenges to use this pattern for this use case. First, synchronous calls are made to downstream system by the payment service, which means that any latency caused by the subsystem affects the overall response time of payment service. The running costs are higher because the payment system is waiting for response from other microservices before responding to the calling system. The total running time is therefore relatively higher compared with the asynchronous system. Error handling and retry are handled separately for each microservices inside the payment system, not by individual microservices. So, to solve this problem, we have a solution of using API gateway pattern to integrate microservices by using multiple API gateways or one API gateway. Use this pattern when you want single entry point for all the microservices, right? Okay, friends, now let's understand the use cases of this pattern. We'll see now where to use this design pattern. So use this pattern when you want single entry point for all your microservices. Use this pattern when you want to break direct communication between the client application and the microservices. Use this pattern when you want a reverse proxy to route requests from client to services. Use this pattern when you want to handle the cross-cutting features like authentication, SSL termination, and cache outside your microservices. Friends, now let's understand what are the advantages we get using the API gateway design pattern. It encloses the whole internal structure of web application and it isolates it from rest of the world. It never calls a particular service, for example, client interaction with API gateway. Client never interact or call the service directly. It has to go via API gateway. It helps in simplification of the code at the client side so that the client has to call only API gateway URL every time. It breaks the tight coupling between the client and the microservices. It creates a proxy where all the requests has to go through API gateway where we can easily monitor the incoming request for all the microservices. Okay friends, now let me summarize what we learned in this video today. I gave you introduction of API gateway design pattern. Then I'll explain the real world example of API gateway design pattern. We saw the use cases of API gateway design pattern. I explained the benefits and advantages of API gateway design pattern. So friend, let me know if you have already used this design pattern in your project or seen a scenario where this pattern can be very useful. Please provide your answer in the comment section of this video. Friends, in the next video, we'll discuss about aggregator design pattern. I'll explain what is aggregator design pattern. Then I'll show you the real world examples of aggregator design pattern. We'll understand the use cases of aggregator design pattern and we will see the benefits of aggregator design pattern. So stay tuned for the next video and keep watching Code One Digest. And if you're new to the channel, so please do subscribe to our channel to grow Code One Digest family. Thank you. Friends, if you like this video, so give it a thumbs up and subscribe to this channel for the more interesting videos. Click on the bell icon for the latest video notifications and do not forget to share this video with all your friends and colleagues. This is very useful information for students, beginners and software engineers. I am putting a lot of efforts in creating these contents. So please help me growing the Code One Digest family. Please subscribe to Code One Digest channel for the latest programming and technology related videos. Thank you.